whole industrial world is talking about edge computing right now. This is the topic I'm talking about with Michael Leipold from Siemens. Michael, is edge computing the panacea for data processing in the industry of the future, or isn't it?
Dirk, that's a nice question. Probably I wouldn't go so far as to call it a remedy, but I think this approach of edge computing and cloud together can be a very compelling approach to tackle the challenges that we do see today in our markets and in our industrial use cases that we have so far not been really capable of addressing with the solutions that we had now on the market.
We want to talk especially about motion control. What are the benefits of edge computing for drive technology in particular?
The thing is, our customers, machine builders and machine users alike, these guys are, to be very open, not so much interested in the drivetrain, but rather the whole machine. But with the drivetrain being a focal and an essential component in each and every machine, I mean, if you look at various kinds of machines, there's always drives inside, and that shows that the health state of the complete drivetrain, and I'm talking about mechanical and electrical domain alike, that this is an essential part of the health state of the whole machine. And with that, we need to basically leverage all possibilities that we have to get this in-depth understanding of the drivetrain, to get the comprehensive understanding of the state that the machine is in. And this is where edge technology in motion control comes in its own and really can provide a benefit to the machine users and the machine builders.
Drive technology and decentralized data processing are basically not a new idea. So what does edge computing have that other technologies or ideas didn't have before?
That's nice. We hear this question a lot of times, and it's a very valid question. Yes, drive technology has been there for the past 160 years, ever since Werner von Siemens came up with the first electrical motor. And of course, also decentralized data processing has been there ever since we started mounting industrial PCs in our applications. Both approaches were little revolutions at the time when they were being introduced into the field of industry, but it's really now that we bring together the benefits of both. Let me go a little into the details of a machine. I was referring to decentralized data processing. If you look at a PLC that is basically controlling the machine, what is happening in the machine is taking care of the automation. This is such an important thing to ensure the operations of the machine and the safety of the machine, that you don't want to risk that. Risk it, for example, with processing data in parallel. So you would want to give that to another instance in the machine. You would want to benefit from that by being able to have low latency data processing, so that you get a quick reaction to the input that you delivered. And at the same time, you would want to do that with high frequency data, so data that are being processed at high sample rates, and we're talking of 2, 3, up to 8, or even almost 100 kilohertz. So this is the part where we say this is very interesting for the processing, the decentralized data processing in the machine. And now bringing that together with motion control, with the drive technology, I was referring to sample cycles of data. This is the part that hadn't been there before. We are now able to make very precise measurements, either mechanically or electrically, at the drivetrain. And with this high resolution data, we can bring in all the calculating expertise and performance to find pattern in these data that we are measuring. Why would we want to do that, you ask? Good. We want to do that, as I said in the beginning, we want to understand what's happening at the drivetrain. We want to see, based on, let's say, pattern in the electrical current signature, we want to identify problems before they basically impact the operation of the machine. And now, after quite some information and details here, I think it becomes very obvious that we can achieve this by taking basically the best out of those already, you called it already there technologies, motion control, addressing dynamic motion, precise motion, all the benefits that you get from our dynamics drive systems, for example, and the decentralized processing of data, not interfering with the PLC, but happening there in a separate dedicated device, an edge device. And bringing this together to the benefit of the customers, this is the focal point that we want to address, and that is really at our heart to generate those value propositions there.
So give us a brief outlook on the future of edge computing in motion control. What can users expect from Siemens, from your company?
Dirk, you and your readers, praise yourself for some exciting new things. The journey has only just begun. I think I'm not promising too much. By identifying and monitoring drives and drive systems during runtime of the machine at very high speeds, this is only the beginning of our journey. The next big thing will be to integrate the complete drivetrain. So I'm talking about all the dynamics drive systems, not only the dynamic servo drive systems with which we started now, but also the standard drive components like our Dynamics G portfolio, so that users in less sophisticated motion control use cases can also benefit from that technology. But we will, on top of that, also include not only the electrical with the drive systems, the electrical domain, but also the mechanical domain, bringing together the strengths of both approaches of both domains. So we will also integrate data from acceleration and vibration sensors, for example. But then again, we are Siemens, and we have not only this portfolio expertise in our drive systems, but also a very profound application experience and use case experience from various industry use cases. And you can count on us that we will bring in this expertise to bear to your benefits. And last but not least, one of the most challenging goals, I would say, is that we want to bridge this gap between the edge and with that the real world in the machine and the virtual world of the machine. And I'm talking about simulation, virtual commissioning and things like that. And this will be the next big thing. And there we will close the loop from virtual world to real world, and again back to virtual world. What do I mean with that? Throughout the value chain, throughout the process of designing, commissioning, and building a machine and then operating it, we will close that loop. We will support with our virtual commissioning offerings the commissioning of a machine and the drive system inside. We will monitor the operations of the real machine that has been then built, And we will feed back that information into our simulation and virtual commissioning models in order to further improve the processes, the commissioning processes, the engineering processes of our customers.
Michael, thank you for this very interesting information about the edge computing in the field of motion control. Many thanks to you.
Thank you for having me and have a great time.